Hi there, this is Sam, a chemical engineer with a passion for solving complex problems and sharing what I learned along the way. On this channel, I break down real engineering challenges from CFD simulations to chemical processes and turning them into simple step-by-step solutions so you can actually use. Whether you are a student, a researcher, or an engineer in the field, you will find practical tutorials, walkthroughs, and honest insights from real projects. And if you are looking for extra resources, downloads, or detailed explanation, everything I cover here is linked on my blog.sam-musavi.com, where you can dive deeper anytime. So if you find this content helpful, don't forget to give the video a thumb up and leave a comment. I read them all and they help shape future videos. Let's keep learning and building smarter solutions together. Thanks for being here once again and welcome to the channel.
In today's video, I'll walk you through how to turn a CT scanned rock image like this one into a CFD mesh. Basically, it's just an image. You can use what image you like or what geometry you have, and you can easily turn it into a 3D mesh ready for OpenFOAM simulation. So basically, if you are working with porous media and want to run CFD on real geometries, you are in the right place. Before I just start, I want to show you some tools that you need to work with in this tutorial. The first one is the paint.net. Basically, it's a very easy tool and open source one to manipulate the images in an easy way and very effective. So basically, it's a somehow simple version of a Photoshop. Not that complicated, but still very handy. The next website that I want to work with is turning the image like the one I showed you into the SVG or vectorized format. SVG stands for Scalable Vector Graphics. Basically, you give it an image like JPG or PNG and it turns it into the SVG. But there are some criteria you should keep in mind. We talk about it when we reach to. The next tool is the Blender. Blender is an open source 3D modeling software, very powerful and absolutely open source tool. The good point about this software is that there are plenty of add-ons that you can add to this software, which one of them is snappyHexMesh GUI add-on for Blender. It is developed by Tuomo Keskitalo. It's a very handy tool and basically it's a fantastic work. So we will reach to this point also in this video. Basically, the workflow is very easy. I try to explain it in simple word first and then jump right in the work. The first thing is that we prepare a image we want, just like this one. Inlet on the left side and outlet on the right side, something similar to this one, or you can just put an inlet on top left corner and the outlet on the right bottom corner. So when you have this image, I will explain it in more details in future, but I just want to show the workflow at the moment. Then you go to the website SVG Online Convert. You can see the address top here and also in the caption and description of the video. You drag and drop the file here just like this and it returns you an SVG file. You simply download it and save it to your own directory. That's it. And then pick this file and drop it into the Blender, do some magic stuff, and then use the snappyHexMesh GUI to export it as a snappyHexMesh dict and also other files. So let's jump straight into it. Let me first delete this file to go through it step by step. First thing is that I installed the image, the paint.net software for the image processing. It's right here. The thing is that you should only have a binary picture here. You are not allowed to have a gray pixel or a blue pixel or something like that. Probably you can have that once, but the thing is that in the current workflow, I'm just focusing on a binary image. The black one showing the pores and the white is the bulk. Basically, the black pixels are the paths for flow to fluid. So it'll start from the left side, go through the maze, and run out of the system through the right side. If you have some other colors or you are not sure if it's binary or not, you can just use the brightness and contrast. As you can see, if I decrease the contrast or increase it, I only can have two kind of colors. So right now I only have black and white, as you can see. RGB colors are 000 for black, and for the white are 255 for RGB colors, red, green, and blue. When you prepare this image, then you should turn it to a scalable vector graphic or SVG file. To do so, you open the convert onlineconvert.com like this one, and let me go back to start it over. You just drag this file and drop it here. It will start to do some works. Then you start the process. It uploaded and prepare the SVG file. You will download it and put it right here. Now you're going to open it using the Blender. So let me first open the Blender software. As I mentioned before, you can easily find the Blender website on Blender software on their website, blender.org. You can just download it. The installation is super easy. I'm not going to show it right now, but I trust you. You can install it by yourself. And then go to the snappyHexMesh GUI add-on. In this website, you have the URL up here. In this website, just go through the installation and the startup part. It says that you should first have the Blender. We installed it already. And then download the code from the GitHub and then import it or install it into the Blender from edit preferences add-ons, install and open the add-on zip file. Basically, you download the zip file from this GitHub repository and then install it on top of the Blender using this tutorial. And then you activate the snappyHexMesh GUI add-on in preferences. I show it very briefly in the video right now. So let me first open the Blender. As the Blender website and the snappyHexMesh GUI add-on said, you can install the add-on from the edit, preferences, add-ons, and then by very tiny button over here, you can install new add-on using install from disk. So you select the file and then click on the install from disk. I press the cancel because I have already installed it, and then you just looking for the snappyHexMesh. So let's see if we can install it just now. To make sure we are on the same page, you click on download zip. It starts to be downloaded. You copy it to your directory. It is not mandatory to copy it here, but just to make sure everything we need is here, I paste it into our workstation folder. Then let's go back to the edit preferences, add-on, and install from disk, and click on it. As you can see, the snappyHexMesh GUI now appeared here and also right here. Next thing is that don't remove whatever you have here by pressing A to select everything and then press delete. So what next? The next step is to import the SVG file. It asks for the resolution and the scale, so you just import it. And also you can import it from the import section in file, scalable vector graphics. Go back to the folder, and then by pressing home button, you can go right away to your geometry. which is here. And then by clicking on the data, you can extrude it to the scale you want. For example, right now I only want to scale it as 0.01 centimeter. It's too much apparently, so I choose much smaller value. Let's put another 0 here. Yeah, it looks okay-ish. And as you can see on top right here, this is the X, Y, and Z direction. So here was the input and this one output, just like the picture we have. The only thing you should keep in mind, if under the material you have some materials imported automatically here, just press remove. It may take a while, but we can wait, of course. So far so good. We have the geometry in the Blender. The next thing is that to turn it into a mesh. So by press F3, a search box will be open, which is some tools. Then you search for convert, and there's an option set convert to mesh. You selected the geometry, press F3, and then say convert to mesh. Now it's a mesh. By pressing tab, you can see how it looks like in the edit mode. By pressing again tab bottom, then you can see the object itself. By right click, I can see some other options. I suggest you to press this bottom shade flat. This is just based on the self experience. Now you have the geometry, and also another option you can do at the moment, after pressing tab and selecting all the edges and vectors by pressing A bottom and then press F3 for search, you can find these trees to quads. It's another self-experience thing and you can use for a better mesh. So now everything seems okay. The next thing is that to select the inlet and outlets directly. So I select the edges first, the first one, holding the control, then select the next one, then the other one, and the last one. Now we have a face over here, which is our input. Just zoom in to make sure everything is okay, and you have the face you want. Then by right click, you can find a separate option over here, and by selecting this option, you will separate it from the rest of the geometry as your inlet. You'll do the same for the outlet. Let's turn the geometry to the other side. Again, the first one, the second edge, third edge, and the right edge. So again, we have the face that we want to separate it as the outlet of the system. So we press again the selection. As you can see, we have two other objects over here. I try to rename it for a clear idea about them. The first one is the walls. This one was the input, and the other one is the output. I press tab to exit this environment and go back to the layout. It's time to get to the snappyHexMesh GUI. We have the input, or let's call it the inlet and outlet. And then the rest of the geometry is the walls. So first thing is that we select the export folder. I suggest to create a new folder and name it as mesh and then accept it. First select the OpenFOAM version. I use the OpenFOAM 12, so it's from the openfoam.org. You can select the number of CPUs, also the cancellation phase, which is an option in a snappyHexMesh, and the snapping phase, and also the boundary layer phase. I do not select the boundary phase right now because it is not important in my geometry that much. The next thing is that max non-orthogonality, which is 35. It's good-ish value for the simulation. And mean triangle twist, feature snap iteration, clean mesh. If it's needed, you can press it. Add location in the mesh object. It's a very important option. You should select the point inside your geometry which is here. Then I try to move it by pressing G and then X to move it in X direction. And I can also do the same to move it in the Y direction. So first I press G to grab it and then Y to move it in the Y direction. This very tiny point is the place that I should put it inside the geometry. By pressing Alt and Z, you can turn on the X-ray mode, which allows you to look into the mesh. As you can see, it is inside, so I just want to move it a bit in the X direction and then move it a bit in the Y direction to make sure it's in a good place. And the snappyHexMesh can see it. So far, so good. So I will press Alt and Z to turn off the X-ray mode and then go back to the snappyHexMesh. Well, by pressing the clean case directory, the case directory, which was the mesh folder, will be empty, and then by clicking the export, it will export it, but it is not something we are currently looking for. So I press clean again. The next important thing is that just make sure the wall type is wall and the inlet and outlets are patch. Basically, they are the main thing here to show that these two walls on the left and right side are the patches and the flow can flow through the system. And then the rest will be the wall. Uh, the important thing here is that to select the cell lengths, basically it shows how tiny a cell can be. I keep something like 0.03. No worries about the size of the geometry right now because you can easily scale it using the OpenFOAM. I will show you right away. And then just make sure the case directory is clean and then export. Let's see what we have here. We have a constant folder, system, case, and run file. I have the OpenFOAM on my WSL machine, so you will go through it to install it on our system and also to mesh it into the OpenFOAM. So let me first move it to my WSL machine and then as you can see here, we have the constant folder, system, case.foam, and run file, which is a bash command to run the whole mesh parts like blockMesh, surface feature, and the snappyHexMesh, and also checkMesh at the end. The only thing that you should keep in mind is that when you select the cell length, it should be less than the size of the geometry in a proper way. It means that it shouldn't be that big. That doesn't capture the whole geometry, and it shouldn't be that tiny that cannot be performed by the CPU. So I will keep it at 0.0005 based on my geometry size and then clean the case directory and then export it. I have it over here, the mesh, the folders, and also the STL files. And in the system folder, I have the blockMesh, control dict, the compose particle if you have the parallel line, and also the snappyHexMesh and surface features. So I will copy and paste it into my WSL directory like this, and I empty the folder and copy and paste all of them into my WSL directory. If you have it on your own machine and it is not a virtual one, you can just take it to your own system. Then I open my terminal like this and I just load my OpenFOAM and go to the folder, and then if it's needed you can give it some access. If you do not have enough permission, then source the run file and let it to be run. It may take a while based on your CPU power and you can just wait at this moment. In meanwhile, I'm going to open the power view to just visualize the mesh, and also I will show you the scaling of the geometry. But in the meanwhile, let me open the power view. Now it's finished and we are going to open it in the power view. But before that, I will take a look into the check mesh. You can use the check mesh command, or you can open the log for check mesh in the folder. Everything seems to be okay, like the aspect ratio, minimum face area, mean volume, and also the total volume of the cell, and also the overall domain bounding box. The geometry right now is something like 13 centimeter in 12 centimeter, and also the thickness is 1 millimeter. As I mentioned, you can easily change the dimension. We will reach to that point, but first let's take a look to the mesh itself. This is the geometry that was created using the snappyHexMesh and the workflow we introduced here. There are two folders have been created here, the first and second castellation layers. So you can just move between them. As you can see, some curvatures have been captured in the second phase. This is the first one and this one is the second. You can choose whichever you like, because this one is much more structured mesh than the other one. Maybe you can neglect the curvature for the sake of the having a structured mesh. And also you can see the inlet and outlets, very structured and very nice geometry. I mentioned scaling the geometry. It's very easy. You can just use the transform command, transform in OpenFOAM 12, and then scale equal to, it's a vector. In z direction, I want to make it 1/10. In x direction and in y direction, I want to again make it 1/10. And in the z direction, I do not want to change anything. It said the mesh have been written into this folder, so I will load the files and show the internal mesh and go to the next one. As you can see, it is much smaller, 1/10 of the previous one, and in the z direction you can easily scale it again if needed. So in z direction it seems to be a bit weird, so I will go back and run the transform. I put 1 for x and y direction. I want to turn it 1/10, which is very small. Let's make half of it and then press. And again, written into the second directory. I reload the mesh. As you can see, the thickness have been changed. If you yet want to decrease the thickness, you can do so. And it was the mesh we have generated in this tutorial. And if you want more structure, you can easily change to other one and use it easily as a simulation with different solvers. That was the full workflow from a JPG rock image to a usable OpenFOAM mesh. If you found this helpful, please hit like, subscribe, and comment below. If you want a follow-up video on running the simulation, let me know. And thank you so much for watching this video.